Please work on the bell assignment at your own seat. Whenever you're finished, you may go to the board and put up a problem of your choosing. You will go over them together as soon as you're finished. Please pause the video so that they can see the bell assignment and work. Go ahead and hit play whenever you're done going over them. What we're talking about today is Lesson 61, Area and Angles of Parallelograms. Recall from Investigation 6. It says recall from Investigation 6. However, you know that we don't do the investigations. So, here's some information for you. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Hence the word parallelogram. Okay? So, our first example is a parallelogram because this side is parallel to this side and this side is parallel to this side. The next one is a parallelogram because this side is parallel to this side and this side is parallel to this side. Okay, meaning if they extended on, they would not intersect. The last one is not a parallelogram because this side and this side are not parallel. If we let those go on, they would intersect. So, not parallel. So that makes it not a parallelogram. In this lesson, we will practice finding the areas of parallelograms. But first, we will review a couple of terms. Recall that the dimensions of a rectangle are called the length and width. When describing a parallelogram, we do not use these terms. Instead, we use the terms base and height, just like we do for a triangle. Okay, we show in the parallelogram here that the base is across the bottom and the height is that perpendicular distance. Okay, notice that the height is not one of the sides of the parallelogram unless the parallelogram is a rectangle, and then of course the height would be one of the sides. Instead, the height is perpendicular to the base, and by perpendicular, I hope that we remember perpendicular means that they meet at a right angle. Okay, so this height meets this base at a right angle or 90 degrees. Okay? So, to find the area of a parallelogram, we take the base times the height. A equals BH, where A is the area, B is the base, and H is the height. For example, Parallelogram Park is a small park in town with the dimensions shown. Find A, the perimeter of the park, and B, its area. First of all, finding A should be relatively easy for us because we have been told forever and ever that the perimeter P is the distance around, okay, around the edges. So that would be this distance right here. So because these sides are similar, we know that since this side is 80, this side is also 80 yards. Since this side is 50, this side is 50 yards. So all I have to do is add those up. So I have 50 plus 80 plus 50 plus 80, and that will give me 260 yards. Now, to find the area, we will use our formula. Area equals base, that's a B, times height. Okay, my base is going to be this distance across the bottom here. So instead of B, I'm going to plug in 80. And my height is going to be where it meets perpendicularly to the base. So it's going to be this distance here, which means that 40. Okay, it has to be perpendicular to the base for it to be the height. So I'm going to plug in 40 for my height. So area has to equal 80 times 40. Therefore, the area equals 3,200 square yards. Figures J and K of Investigation 6 illustrated a straw rectangle shifted to form a parallelogram that was not a rectangle. Two of the angles became obtuse angles, and the other two angles became acute angles. So this is the original figure, and then they just took the sides and they smushed them a little bit. They scooted this one to the right and they scooted this one to the left so that they sit at an angle. All of the sides are still parallel to each other, but they may be just shifted a little bit. Okay? So, in other words, two of the angles became more than 90 degrees. Just looking at this, we can see the two angles that are more than 90 degrees. We know that 90 degrees meets at a right angle or is perpendicular. So, the sides that are wider than this would be here and here. Those are the ones that became more than 90 degrees. And two of the angles became less than 90 degrees. That would be here and here. Each angle became greater than or less than 90 by the same amount. If, by shifting the sides of the straw rectangle, the obtuse angles became 10 degrees greater than 90, which is 100 degrees, okay, then the acute angles became 10 degrees less than 90, which would be 80 degrees. Okay, so if this one was 10 degrees more, we're saying that this would be 100 degrees here. This side would also be 100 degrees. This side over here would then be 80 degrees, and this side is 80 degrees. Okay, so a couple rules they give for us. Non-adjacent angles, which means angles that are in opposite corners, have the same measures. So opposite corners, that would be this corner, and the opposite corner is on the opposite side. They have the same measure. The same goes for here. This corner's opposite would be on the opposite side. They have the same measure. Adjacent angles are angles that share a common side. They're supplementary, which means their sum is 180 degrees. So, angles that share a side, and I'm just going to erase this stuff here real quick. Okay, we said that this was 80, 100, 80, and 100. Angles that share a side, I have an angle here and an angle here. They share this side right here. Therefore, they are supplementary angles. That means when I add them up, they have to equal 180 degrees, which is true. 100 plus 80 equals 180 degrees. So, in parallelogram ABCD, the measure of angle D is 110 degrees. Find the measures of angles A, B, and C in the parallelogram. There's one angle that we can find without doing any work whatsoever, and that is the angle that is opposite of angle D. The angle opposite of angle D is angle B, and it has to be equal. So I know without doing any work that angle B measures 110 degrees. The next thing that I know is that I have a pair of adjacent angles sharing a common side. Angle D and angle A share a common side. That means that angle D, which was 110 degrees, plus angle A has to equal 180 degrees. To get A by itself, I'll subtract by 110 on both sides, leaving me with A equals 70 degrees. And because A is 70 degrees, its opposite angle has to also be 70 degrees. Okay? Today your homework is lesson 61, A through J, 1 through 5, and 12 through 30 even. It will be due tomorrow when you walk in the door. Make sure that you are working, not talking. Please remind Mr. Woods to read you the working lunch list, and have a good day. Be good.